Good afternoon, everyone. It's time to start our third webinar in our series of dairy webinars this winter. Our topic today is optimizing production of dairy cows by ensuring good feed access. And with us today is Dr. Trevor DeVries. Trevor is an associate professor and Canada Research Chair in Dairy Cattle Behavior and Welfare in the Department of Animal Biosciences at the University of Guelph. Trevor is involved in teaching and research in the areas of dairy production, nutrition, behavior, and welfare. His areas of research include understanding the effects of feeding management on behavior of dairy cattle, effects of early feeding management and housing on calf and replacement heifer feeding behavior, and the effects of housing and management on the behavioral patterns and risk of illness in dairy cows. So welcome, Trevor, and we appreciate you making time to visit with us. And visiting this way involves a whole lot less travel than you coming down from the University of Guelph. So we'll turn it over to you.
Great. Thank you very much for the kind introduction and for the invitation to speak to you today on this webinar. What we're going to be presenting today on this topic of optimizing production of dairy cows by ensuring good feed access is largely a collection of research that we've done over the years, specifically focused on the feeding behavior of dairy cows. And as just introduced there, my core interest is cattle behavior, specifically focused on feeding behavior and the interaction of that behavior with nutrition, with nutritional management, housing, and using that behavior to or as a metric really to understand how cows respond to those things, and then using that to make management decisions. So what I'd like to do is walk you through much of that research that we've been involved in over the years in today's webinar. When we think about dairy cattle nutritional management, there's a whole bunch of factors or things that we can consider. And first off, we often think about dietary formulation, and rightfully so, starting with good feed, growing good feeds, purchasing feeds, making sure that we have the required elements that we need to put a good ration together, and then using the information about those feeds plus the knowledge that we have of, say, nutrient requirements of cattle, and putting that together in terms of dietary formulations. And we have a lot of very good knowledge on that front. Producers put a lot of time and effort into, again, making sure they have those quality feeds. We work with nutritionists to make sure that we have targets in terms of production and outcomes that we want to see on the farm, and we can use those models to predict what the rations that we're putting together should result in on farm. And so that's kind of a first step there. The next step is actually putting that ration together, and we, again, put a lot of time and effort into making sure that that ration gets put together well. And then finally that ration actually gets delivered and put in front of the cows. And that's really what I want to speak about today in particular. Is we can do a very good job on the front end of this management in terms of making sure that we have the right feeds, we have everything on paper looking well. We can even do a good job in terms of putting that together. The next question or step becomes, well, how does the animal actually interact with that feed, and are they getting full value from that feed that's put in front of them on a day-to-day basis? And three areas that I want to talk about at the beginning of my webinar here is really how the cow interacts with that feed, in terms of, does she eat the feed in the kind of the required amount? Does she do so in a healthy manner, and does she do so as formulated? And what I want to talk you through is how the behavior of the cows is crucial when we consider these three areas. And then after that, going through that importance, and then give you some practical take-homes as far as how we actually manage feed to achieve the things that we want. And so for the first part of my presentation, I'm going to cover more of the theoretical reason why these are important things for us to consider. We'll take a break at that point and hopefully answer some questions. And then in the second half of my presentation, we'll go through is how we actually apply that knowledge from a real practical standpoint. And so the first thing that we need to think about when we think about dairy cows is the fact that dairy cows are kept to produce milk, and there's a number of factors which influence milk production, obviously. However, one of the things that we know is a limiting factor is always how much the cow consumes. And one of the things that we know is that the amount of feed that a cow consumes is going to be inherently tied to her eating behavior. And it sounds quite simplistic, but it's good for us to think about the fact that if we want a dairy cow to eat more feed and thus increase her nutrient consumption so that she can meet the demands of increased production, we need to realize that she just doesn't magically eat more feed. She has to actually change some aspect of her eating behavior to make or to realize that change in eating behavior, or sorry, that change in intake. And so I like to use the schematic that you see here on the screen as an example of that. And when we think of, say, the dry matter intake of the cow, say over here, what we know is that it's really a function of these different aspects of the eating behavior of the cow. So, for example, if we want a cow to consume more feed, she either has to change, say, the number of meals per day that she has, so her meal frequency, or the size of those meals, or some combination of those two factors, because we know that the amount of feed she consumes is going to be a product of, say, that meal frequency and the meal size. And so if we want her to eat more, she's going to have to do one or two of those things. And similar logic goes behind the time course of eating as well. So you see the amount of time that the cow spends eating, so the minutes per day she spends eating her food, multiplied by the speed, the rate at which she consumes her feed, is going to indicate the dry matter intake level of those cows. And so what we know is that if we're going to promote that intake level, we have to somehow influence that behavior of those cows. The question for us then becomes is, well, what is most important for the cow in terms of driving that intake, or how do we most positively influence that intake level of those cows through the behavior? And this is something we've actually been looking at recently in some of our research, and actually taking a number of years worth of research where we've collected data on individual dry matter intakes and looked at correlating that to different aspects of behavior, trying to predict, okay, what are the best predictors then of, say, increased dry matter intake in cows, or what behaviors are associated with that. And so what we have on the screen here now is an example of that data from an analysis we did a couple of years ago, where we looked at trying to identify what behavioral predictors were best associated with dry matter intake, and specifically feeding behavior predictors. And as you see in the text here, the two most positively associated factors with intake level were feeding time and meal frequency. So really the amount of time that cows spend feeding at the bunk, as well as the number of meals that cows had per day as well. What's interesting is that, yes, the rate at which they consume their feed and the size of meals were important, or in our analysis came out as being important, but not as much as, say, the amount of time cows are spending eating and how often they basically got up and down and went to the feed bunk per day, and how many meals they actually had across the day. And you can see an example of that here in the figure that's on the screen. So this is the amount of time cows are spending at the feed bunk per day. associated with dry matter intake level. And what you see for the most part is most cows spend between, let's say, 2.5 and up to about 6 hours per day at the feed bunk across the day. And what you see is this positive association where it's our highest intake cows which are also spending the most amount of time at the feed bunk per day. Now, as you can see from this figure, it's not a perfect relationship where not every cow, there are some cows that eat somewhat faster, some that eat somewhat slower, but in general, those cows that are eating the most are going to be the ones that are going to be spending the most time at the feed bunk. And again, I think that's important for us to think about, and I'll move into that later on in my presentation, is to think about, okay, how do we then make sure that cows are not only stimulated to get to the feed bunk at multiple time points across the day, but at the same time, do they actually have physically the amount of time that they need to actually spend time there and consume their feed across the day as well, both being very important for maximizing that intake in those cows. The other aspect of eating behavior which is important is the fact that we know that how the cow eats her feed doesn't only impact the total amount of feed that she consumes, but it also impacts how the cow actually digests her food, or as I have on the screen there, her rumen function. And hopefully you can see on the screen a couple of videos playing. One is on the left side, a cow grazing, where on the right you see a cow consuming a TMR. And the reason I show these is because it's always good for us to think about what the cow is really designed to do versus what we ask her to do from an eating behavior standpoint. And when we think of a dairy cow, we think of a grazing ruminant, and the dairy cow, from her mouth parts to her digestive system, are really there designed and adapted to be able to consume feed through grazing. And we've changed a little bit of what we've asked of the cow by putting feed like a TMR in front of cows. And what I'm trying to say is that when cows are grazing, they're going to be consuming their feed in a lot different manner than, say, a cow that's eating TMR. A grazing cow would spend probably 8 to 9 hours a day grazing her feed. She'd be taking very small bites repetitively in a series, chewing once in a while, swallowing, repeating this process over and over, and she'd be consuming a nearly all-forage ration, maybe being a little bit selective while she's eating. If you contrast that to the cow eating TMR here, again, if you just watch the mouth parts of the cow, she no longer has to really graze. We've taken that grazing aspect out of the picture for that cow because we've actually done the cutting for the cow in terms of the feed itself. And so all that cow needs to do in that scenario is really grab large mouthfuls of feed. And what we know is when we watch the behavior of those cows eating TMR is that they'll probably consume, as compared to, say, a grazing animal, twice as much dry matter in anywhere from about 50% less time, maybe even a third of the amount of time. And so they're eating a lot more feed in a much quicker time pattern. And it's not only the time course of eating that's different, but it's also what the cows are actually consuming. So rather than consuming an all-forage ration, now we're feeding cows a diet, which in a lot of cases would be typically about 50% forage on a dry matter basis, with about 50% high energy, high protein concentrates. And that rapid intake of a much more concentrated feed source then potentially has implications on how that cow actually digests her food. And we've probably heard this and seen this before, but I like to reiterate the fact that we know that when cows consume their feed in such a manner, when they eat things very fast, when they have a very large meal, particularly if there's a lot of highly fermentable things in that diet like grain sources, we're going to see an impact on the rumen environment. And in particular, when cows have very few large meals, we see these very large declines in rumen pH post-eating, associated with the accumulation of volatile fatty acids, which occur as a result of that digestion of those carbohydrates. The starch that gets into the rumen gets digested very quickly, gets converted by the rumen bacteria into volatile fatty acids, which is then accumulates and causes these drops in pH. And you kind of see a classic example of that on the slide, which I have up right now, where this is a pH trace from a cow from one of our studies from a number of years ago, where what you see is over a 24-hour period, you see the pH of the cow's rumen across the day kind of moving up and down. Typically, a rumen with an average pH, in this case, just about 6, so about 6.2, 6.3 on average, would be described as being pretty good. We want, ideally, we want that rumen pH close to neutral as possible. That would be great. The challenge that we have in this particular case is the fact that we have all these individual drops across the day. And just as an example, if I put a line on here, I put a line at, say, a pH of 6, we see a number of time points across the day, probably in this case anywhere from about 4 to 5 hours of the day, where this cow is spending with her rumen pH depressed below that value. And why that's important is that any time that cow spends with, say, a depressed rumen pH, what happens is a change in the rumen environment. In particular, we see things like fiber digestion being slowed down, so the bacteria that digest fiber aren't as active or aren't as efficient when we get down into lower pHs. And we also see at the same time an increased risk of things like butterfat depression occurring because of some of the impacts that low pH have on the transformation of fatty acids in the rumen and kind of the downstream effects those have on milk fat production. And so this is really something that we want to avoid, and we want to avoid these within day depressions in rumen pH. And then the point I want to make with this figure here is, in this case with this cow, we could directly link each of these depressions in rumen pH to, say, a large meal that cow is consuming. And so our task then is to find ways of trying to level that off and trying to prevent those depressions from being observed, say, across the day. So the alternative then is to try to promote eating patterns which are more stable across the day, so longer feeding times, slower feeding rates, and I didn't put it there, but say having more frequent, smaller meals across the day. And what that results then is a much more consistent flow of nutrients into that rumen across the day, spaced out across that 24-hour period, resulting in a much more consistent fermentation, digestion pattern of that rumen. In addition to that, with increased feeding time, we also see more chewing while eating, and so I put on there more salivary secretion, so cows will chew more while eating, they'll secrete more saliva, which also helps then buffer the rumen, keep it more stable. And at the end of the day, what you see is a more stable rumen, which also then is more conducive to things like good digestibility. And going back to where I started, if we're trying to promote intake in cows, one of the limiting factors that we know, again, with cows in terms of intake is how fast material passes through, and fiber digestibility is often one of those limiting factors that we talk about. So anything that we can do to keep that rumen more stable, get fiber moving through it more quickly, is not only going to have health benefits for the cat, but it's also going to have intake and production benefits as well. I just wanted to show you this example of another pH trace, just to show you what that could look like. Quite interestingly, this data here is similarly from one cow, one 24-hour period, from the same study I showed you earlier. This is a different cow, but very similar level of production, similar level of dry matter intake. And it's curious to note that you see a very different pH trace in this cow. Not only is the average quite a bit higher, but you don't see those distinct kind of within day depressions as you saw in the previous figure. In this case, you see some smaller depressions, but they're not as large and succinct as you saw in that previous figure. And again, when I looked at these cows and looked at the difference, really the difference in this case of this cow here is a much more stable eating pattern across the day, where this cow is having much smaller, more frequent meals, preventing those, say, large within-day depressions, which again, as I mentioned, are conducive to, or in this case, conducive to better rumen health and better production. So putting this together from a cow behavior standpoint, what we need to be thinking about is trying to encourage eating patterns that, again, are going to promote intake, but also things that are going to keep that rumen environment stable. And when we do that, we see production benefits of that. It's not just theoretical, and I just have a couple examples. This is some data pulled out of one study from a couple of years ago where we just simply correlate meal frequency, so the number of meals cows have per day spread across the day, and say milk fat content. And again, all these cows, similar production level, similar diet. What you see is this positive association between meal frequency and milk fat content, where cows that are having more frequent meals per day, smaller meals in fact, more frequently spread across the day, more stable rumen environments, again conducive to improved milk fat in those cows. And that then, in addition to the impact that, say, this kind of eating pattern has on intake, has a positive then impact on total production level in these cows as well. So just the same data set, but in this case looking at fat-corrected milk production in these cows, you see a similar positive association, where we see those cows at the highest level of production also being the ones with most frequent meals across the day. Again, not a perfect relationship. We see some variability around there, but it's really those cows that, if we're going to be pushing production on, we need to make sure that they, again, get to the bunk as often as possible so that they can maximize their intake, but also stabilize their rumen environment at the same time. The other aspect of eating behavior that I wanted to touch on from a kind of theoretical standpoint is what the cow actually consumes. And it kind of goes back to what I mentioned at the beginning. We want cows to eat their feed in the amount required in a healthy manner, but we also want it to be consumed as formulated. When I started my presentation, I mentioned the fact that we put a lot of time and effort into putting together good rations for cows. And one of the reasons why we developed TMR rations 40 years ago was the fact that we wanted to basically provide this nice blend of ingredients to cows so that they didn't need to be selective, but that they were going to, in every bite, basically achieve the nutrient intake or the balance of nutrient intake that we wanted those cows to consume. But we know is that, as you see in the video hopefully showing on your screen, and if you ever watch cows that are fed a TMR, one of the first things that cows do in that scenario is to actually try find the bits and pieces of that diet that they want to consume, and try to avoid potentially some parts that they don't want to consume. And again, it shouldn't surprise us that if we put a mixed ration in front of cows, that they're going to try to eat certain things or avoid certain components. And even if we do a really good job of making sure, say, our forages are cut very well and it's very well mixed, the cows will still do that. And typically what we see is cows selecting against fiber, selecting for the more digestible, highly fermentable portions of the ration. And that at the end of the day can really have two results for that cow. Number one is, and again, if they're not consuming enough fiber, shouldn't surprise us that we see the rumen environment being affected by that. So again, going back to some of these things I was describing earlier, cows aren't consuming enough fiber. Well, that can decrease rumen pH and have negative impacts as a result of that. And the other side of it is, the minute a cow sorts, for one thing, what it means is that the feed that's left in the bunk is going to be different for the next cow that's going to consume that feed. And so the more sorting that occurs within time periods of the day or across the total day, what it does is it introduces variability in terms of what cows actually consume, not only individual cows, but particularly in a group environment, it's going to increase variability between cows in terms of what actually gets consumed across the day. And I just wanted to share with you, this all sounds nice and theoretical, but we actually have very good data to support some of these effects. And I just wanted to share some of that with you now. This is some really interesting recent data that comes from one of our studies that we published this year, where we were looking at sorting of a TMR at a cow level and correlating that to different production outcomes. And in this case, we were looking at sorting of the long particles of a Penn State shaker box. So basically the top screen of as you see on the bottom left-hand side of your screen there, the top screen of a shaker box. And what we did is we looked at, for that top screen, how much of that actual amount of long particles was consumed by the cows relative to how much we predicted those cows would consume based on the ration put in front of them. And so what you see on the slide is two figures of data. The one here on the left-hand side showing the amount of sorting, so particle sorting, long particle sorting, as a percentage, where 100% is really the cows eat exactly what we predict them to consume. Anything under 100% would mean that those cows are selecting or sorting against those particles, and that's what we typically see. So we see numbers less than 100, meaning those cows are selecting against those long, more fibrous forage particles. And what's kind of neat about this data is you see this nice correlation here. I have the line here where basically as you move from the right side of the figure to the left, basically as the cows select more against that those long particles, we see lower milk fat in those cows. And again, going back to the theory I was kind of mentioning before, this shouldn't surprise us too much. As cows select against fiber, we have increased risk of subacute renal acidosis, and some of the downstream effects of that are things like milk fat depression. So that association, not unique to this study, we've actually shown that a couple of times before, but it does show the negative consequences at a cow level, which can happen simply by sorting. Interestingly, in this data set, we don't only see that same relationship just with milk fat, but we also see the same with milk protein. So down here on the right, bottom right side, we see similar graph, except we see almost a similar type relationship, a little weaker, but where we see basically more sorting against those long particles, we see again lower milk protein. And again, what this tells us is it's not just, say, fiber, and it's not just the balance of that rumen from a, say, an acid standpoint, but it also is the balance of nutrients being consumed. And so anytime that cows aren't consuming that balance of nutrients as we expect them, we're going to see production effects of that. In particular, we're going to see cows not meeting the production targets that we hope them to achieve. We don't only see this at a cow level, but we also have observed this at a herd level. And I just wanted to share with you one result at a herd level as well. That we did a study about 4 years ago now, where we went on farms in Canada, all TMR feeding herds. These are all freestall herds where we went on these herds for 7 consecutive days in the summertime and wintertime, taking samples of their TMR fed to their high group of cows. And we sampled that feed at the beginning of the day, and then we also sampled their feed at the end of the day. And what we wanted to do was look at how much sorting cows were doing at a group level, and then associating that with some production metrics that we had on those farms. And what you see here is the results of one of those associations, where we found on these farms that we surveyed that every 2% refusal of long particles, so again, the particles sitting on top of this Penn State shaker box here, as you see on the screen, every 2% refusal of those was associated with about a 2-pound drop in fat-corrected milk and a 2% decrease in production efficiency. And doesn't sound like a ton, maybe it does, but across our study herds, we had some herds that at a group level, cows were refusing about 10% of the long particles in their diet, and some herds basically not refusing any, so there was no observable sorting on those farms. And so across that range of, say, 0 to 10%, if you multiply that out, that's about a 10-pound difference in fat-corrected milk that we could predict across those farms just based on the feed sorting of the cows. And again, if you think about all the factors that influence milk production and our ability to change milk production, particularly within a geographical region where everybody's feeding very similar feeds, there's not much you can do to predict a 10-pound difference in milk production that easily simply by changing, say, the ration. But in this case, just by controlling the behavior of the cows, by getting those cows to eat more consistently, i.e. closer to what we expect them to eat, we can actually correct for a large proportion of variance that we see in production between herds. So again, just want people to think about the importance that behavior has on not only that individual cow, but then the group as a whole as well, in terms of us meeting, say, some of our production targets that we have on farm. And so that kind of brings me to the end of the theoretical part of my presentation in terms of describing to you why we need to consider the behavior of the cow, and what differences in feeding behavior can translate into from a production standpoint. The next part of my presentation is going to focus on taking that knowledge then and actually applying it to our feeding management practices and thinking about the broader implications, the more practical implications of that knowledge. So I think this is a good point. I think there's maybe a question or two out there, and if people want to ask a question, this is probably a good time to do that. So I'll turn it over to our moderator to pose those at this time, if there is any.
Any questions out there? Trevor, on the slides you were showing with the suppression in energy-corrected milk with sorting, it sounded like there were multiple herds that you looked at. What were the differences in the rations that were being fed? Was there anything you could see there?
Yeah, so that was a study done with, there was 22 herds in that study. And again, multiple observations, as I said, about 14 days of total individual time point collection. All the herds were in a fairly tight geographical region, so probably all within about a 50-mile radius of each other.